Okay, so in IM1, we're going to start 7.1 by examining data analysis and displays. So the first thing we're going to look at is a frequency table. This one shows us the number of books that 12 people read last month. So we're starting with small numbers. We'll get bigger later maybe. So they want you to display this data in a histogram. So this is a histogram, and we want to understand what a histogram is. So we take a histogram usually has ranges, so you can see that in the frequency table. And they're usually common numbers, so it'd be 0 to 1, 2 to 3, or maybe 0 to 5, 6 to 10. So they usually have the same range of numbers. And we're going to put them in what we call bins. So the bins of the range go here. So those are our bins. How do you put the data in the bins? Well, so now we've got our 0 to 1. 6 people read that many books. We're calling it frequency, but it was actually 6 people read that many books last time. Remember, we're talking about people. So when you're making this part of your graph, okay, you want to look at the biggest number and then probably add one to it so you have a little space at the top of your histogram. Then you're making a bar in your bin. So you're going to take equal measures. Okay, you're going to divide it in equal measures. And you're going to make a bar that goes up to the line. These should be equal as well. Okay, so 6 is right here. And so we would make a line and then we connect it down here. So on graph paper, maybe you'd use 2 lines here to go over so it looks like a bar. Then we look at 2, 3. The maximum is 4. So we go up to 4 and we make our bar. For 4 and 5 books, nobody read 4 to 5 books. So we don't put anything there. The bar is empty. Okay, and having 0 data is significant. That's important. We might want to ask, why didn't anybody read 4 to 5 books? Okay, so you do a study and figure that out. Then the last bin that has numbers in it is 6 to 7, and there were 2 people that read 6 to 7. And so we'd put our bar in there. So how do you read a histogram? If you got the histogram first, and there was nothing else with it, no table or anything, then you would look at it and you would say, oh, look at this. The number of books read last month was, wow, 6 people read 0 to 1 book. 4 people read 2 to 3 books. 2 people read 6 to 7 books. So that's how you read the histogram. Okay, so I'd like you to think about doing one of these histograms on page 188 in your journal. Before you push pause, I want you to think about what you're doing. So the first thing is you want to ask, how many bins do I have? In this case, you have 3. In this case, you have 4. Remember, the bins are on the vertical axis or the horizontal axis or the x-axis, okay? Then you want to look at your maximum so you know how high you need to make it. You want to have a title, and it's telling you kind of right here what you're talking about. And then you're going to put number of hours of homework here. And then you're going to put the frequency, which is the number of people that did that. So go ahead and push pause and give one of these a try and see how you do. Okay, so hopefully your histogram looks something like this. Now, when you're reading a histogram, it's important that you don't get mixed up and think that the data is going down. It's not. It's saying that 16 people watch 0 to 1 movies, 12 people watch 2 to 3 movies. So actually, they're watching more people, and more movies, and 8 people watch 4 to 5 movies. So as the number of movies goes up, the number of people is going down. Okay, so that's a negative correlation. Now look at this one. There were 8 people that studied for 0 to 1 hours. There were 16 people that studied for 2 to 3 hours. There were 4 people that studied 4 to 5 hours. And there was, looks like 1 person that studied 6 to 7 hours. So you have to make sure that you're reading the data correctly. Okay, the next kind of data display that we're going to look at is called a circle graph. And sometimes these are called pie charts. but they're not easy to make. They're kind of difficult. So what you do, the first thing you have to do is you have to total up how many people took the survey. And here is the total. Okay? Then you have to take the portion, okay, the portion over the whole, or the part over the whole. So it's the 25 over 45, and then you're going to multiply that times 360, and that will give you the degree of your circle. So the first thing you do is maybe you'd construct a circle with a compass, and you want to make a diameter. So you've got your center point, so you would create a diameter. That will give you a place to put your protractor. So when I start, I'm going to put my protractor right here on this line. Okay, I'm going to do the museum one first, and I'm going to put my protractor on here with the hole over there, and I'm going to look for the measurement 200. Okay, so that's the water park. I'm looking at that one. I'm looking for 88 degrees. So when I get to 88 degrees, remember the inner side is the ones that are less than 90 and the outer is the bigger. So I get to 88 and I'm going to mark that. Okay, then I'm going to move my compass over. I'm going to use a different color here. I'm going to move my compass over. I'm going to put the circle here again. The zoo is 40 degrees. So I'm going to look for a measure that goes through 40 degrees. And I'm going to make that mark. And I'm going to write zoo out here. And I'm going to do everything else nice and neat when I'm done. Other is 32 degrees. So I'm going to move my compass again. Use the purple. And I'm going to put my compass here. And I would measure this. Look for the line that goes to 32. And remember, all of these would be less than 90, so don't make a mistake and use the other number on your protractor, because that will give you an obtuse angle, and these are all acute angles. So now that I've done the other three, what's left over is my water park. And it's harder to do acute angles on your protractor, so this is probably the best bet, is to do the three smaller ones, and then what's left over is going to be your 200 degrees. Okay? So that's how you calculate, and that's how you divide the circle. There will be nothing like this on the test, but I say give it a try. So here you go. All right, so I'm going to put the pictures up there, but I want you guys to try to figure out the percentages that you're going to need in order to do this graph. And I'll do one for you. So the first thing I'm going to do is the total number here is 18. Okay, so when I'm figuring out vanilla, I'm going to say 5 over 18 times 360, and that equals 100 degrees. So again, start by making a diameter, put your protractor on there, and this one's over 90 degrees, so you're going to go this way and go past 90 degrees to get to 100 degrees. Okay? And then you're going to put your line. And then any way you're starting, remember, you're always going to start from the new spot. So if I was going to do, I want a flat line, so if I'm going to do butter pecan, okay, so I'm going to do butter pecan this time. I'm going to do 3 over 18 times 360, and that equals 60. Okay, so I'm going to take my compass, I'm going to put it here with my circle here, and I'm just going to measure up here to 60 degrees. Okay, so it doesn't matter which way you go, but you have to start to make sure that this is 60 degrees. Okay, so give one of those a try and have fun with that. Otherwise, just check your work, make sure you know how to calculate it, and you're good to go. Okay, right here is a display of a bunch of different data displays. Okay, so we have a pictograph where they actually have pictures showing the data. We have a bar graph, which we've used before. Notice that bars are not stuck together. They have a space in between them. And then you would put the data around it. They have specific categories. A circle graph is what we've already looked at. A line graph, those we have been using all year. This would be called a piecewise graph because it isn't a straight line. Histogram, we talked about that already. Stem and leaf plots can be kind of confusing, but each of these numbers, you have to have a key. So you would say 1/2 equals 12. So I would read this 10, 12, 13, 16. This would be 39. So that key tells you how to read it. Those are kind of confusing though. We're going to have a whole unit on box and whisker plots. Dot plots are really important when we're talking about the shape of a graph. And dot plots just would have like 2, 3, 4. So there was 1, 2, 2 3s, 3 4s, etc. And then a scatter plot, which we talked about a little bit when we did regression. So all of these are different ways of looking at the data. So you're going to be expected to use most of these as part of your homework problems in this chapter. If you're not sure how to do them, then ask. The main ones that we'll be using are these, and these ones will all be on your test. So just know that. Maybe a bar graph. I haven't made the test yet, but know how to use those. I will not have you making circle graphs. Okay. Now we're going to start talking about measures of center. The most common measures of center that you've probably heard before are the mean, the median, and the mode. But we're going to start by discussing an exploration. So let's go to your journals and look at this exploration. So they want you, so the first thing you need to look at is what are they showing us here? So these are the weights of players on a football team. And they show them by position, so you could color code it. So the tackles are the dark blue, and the light yellow is other players. The pink is the quarterback. Okay? Then over here is the weights of players on a baseball team. And the infielders are the beige, and the pitchers are the blue. Okay, so it says describe the data in each graph in terms of how much the weights vary from the mean. So the nice thing is, I calculated the mean for you, and the mean, which is abbreviated this way, that's the mean, is 245 on the football teams. So 245 is right about there. So how much does it vary? So the biggest variance in the football team is about 90 pounds. That's a pretty big variance going either way, okay? The variance on the baseball team is about 40 pounds. So what that's telling you is that the weights of a football team vary by a lot more than the baseball team. Okay, then they want you to compare how much the weights of the players on the football team vary from the mean to how much the weights of the football players on the baseball team vary from the mean. So I already said that these vary by a lot more than these. So I kind of answered that question in number 1. Okay? Then the last question is, does there appear to be a correlation between the body weights and the positions of the player in professional baseball? So let's look at the colors. And most of these are right here with a couple of exceptions. All of the purples are here, the pinks are here, the blues are here. So yeah, there seems to be a direct correlation between the positions people play and their weights. Okay, so in football, the answer would be yes, there is a correlation between the position and the weight. But if you look at baseball players, the infields are here, are here, are here, are here, are here, and then the pitchers are all over the place, and the outfielders are all over the place. So I would say for baseball, there is no correlation. Okay, the baseball players, there's more spread out, so there's no correlation. The football players, each position is clustered together, so they are similar weights for the similar positions. So it's just getting you thinking about the different things that you can see in different kinds of data. Okay, so like I mentioned before, our basic centers of measures of center are the mean, median, and mode. So how do we find those? So the way to find the mean is to add up all these numbers, and they equal 40, and then you divide by the number of numbers. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to divide by 10, and the mean is 4. Then to find the median, we have to put the numbers in order. So 1, 2, 3, 3, 3, 4, 4, 5, 7, 8. We already know that there's 10, so we're just going to count 1, 2, 3, 4, 5. I put a line, that's how I do it. 1, 2, 3, 4, 5. I always double check to make sure that it's halfway. And then you would take these two numbers and find the average of those. So my median is 3.5. And then the mode, when I was a kid, mod meant popular or new. So I think of mode as the popular one or the one that is there the most often. So my mode in this case is 3. And so now you can look at the data and say, how do these compare? So there's a lot of big numbers. And so I would say the mean would probably represent these numbers best of all. Or maybe even if you said, since there's lots of small numbers, then this one is a little closer. So it depends on how your data is set up. And we'll talk about that in a minute. Okay, so I just wanted to put this out here first because they ask you about this on your homework and they don't talk about it till the next unit. So here are 3 different data displays, and I want you to look at them and see how the data is aligned. So when you see the data where it kind of makes a mountain in the middle, that is called symmetrical. Okay, and the median is usually very much in the center. And the mean is also in the center. We can see the mode because that's the highest one. So we don't really use the mode much. So that's why I'm not putting it there. But when it's symmetrical, the mean and the median are very close together. When your mountain tips over and it leans towards the left, it is called skewed right. So you have to kind of remember, if it's leaning left, it's skewed right. Okay, when you have a skewed right, you're going to want to use the median as your center data that you use because it will be more in the middle. These bigger numbers and the bigger frequencies are going to pull the mean over. So the mean will be offset, okay, and it will be over towards the bulk of the data. Okay, when you have a mountain that is leaning to the right, that is called skewed left. Okay, this one, again, you would want to use the median because it will stay with the center of the data. The mean is being pulled to the right. Okay, it's being pulled over to where the bulk of the data is. There's more numbers over here. 1, 2, 3, 4, there's more numbers. So that means the mean is over. So when it's skewed, we're going to use the median to evaluate the data. When it's symmetrical, we're going to use the mean because mathematically it's more accurate. They'll be close, but the mean will be more mathematically accurate. Okay? So these data points, to calculate these, we still need the exact data. But this is just showing you that what you would look like on a basic graph. Okay? All right. So now we're going to compare the measures of center. So an amusement park hires students for the summer. These are their hourly wages. They want you to find the mean, median, and mode. So they added up all the wages, so there's 8 of them, and they divided by 8, and they got the mean as $9.65. Then they put the money in order, and they found the center. So remember, you have to, if it's an even number, you have to add the 2 together and divide by 2 to get your median. Okay? It's the mean of the 2 middle values. And then the mode is the most popular, so there you go. Now, then they want you to evaluate which one do you think is the best measure of center. Well, look at the mean. It's 965. And if you look at your data, 965 is way over here. It's not even close to most of the data. So I don't think I'd use it because it looks like it's going to be skewed. There's going to be this one high one over here, but most of the data is down here. So it's not going to be symmetrical. The median, however, is right here, right in the center of the data. And so it's a pretty good use. We're not going to use the mode ever as our measure of center, but it's important to know that it's 825. That's probably the starting wage, and since they're always having high turnover, then that's what. Now, so the median best represents the data, The mode is less than most of the data, so that's another reason we wouldn't use it, because we don't know if it's a less, more, whatever. And the mean is greater than most of the data. So this best represents the data, okay? And this is telling you that the mode can be non-numerical, which is also why it doesn't always have any value. Okay, so I want you guys to do number 1 on page 193, and I'm going to give you the total number, which is the sum. This is the sum of the data. That means sum. Okay, so if I add those all up, it's 45. N is the number of data, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So N equals 9. So now that you've got those numbers, you can very quickly find the mean. Then I want you to find the median. You're going to put the numbers in order, and then you're going to find the mode. So just push pause. Don't forget you're going to want to determine this before you come back on, and we'll see how you do. Okay, so the mean is 45, which is the sum, divided by the number. So it's the sum divided by the number, and that is our mean. So we get 45 divided by 9 is 5. Okay, now remember I told you have to put them in order. So we're going to go ahead and put them in order. 2, 2, 2, 3, 4, 4, 5, 7, 16. Okay, so now that we've done that, we're going to go to the middle. There are 9. So the middle number, which is 4. So the median is 4. And then the mode is 2, because it's the most popular. Okay, so there's our different numbers. You can see that it's a big disparity. Again, which one did you pick? They said again that the median, they would choose the median because the mean is greater than most of the data. So here's the median. It's greater than most of the data. And the mode is less than most of the data. So that's why they picked the median. Okay, an outlier is a data value that is much greater than or less than the other values in the data set. So we're going to look at an example. This is the same one that we used before with the wages at the water park. And we're going to identify the outlier. So what's the one that's way higher or lower than the others? And it's the 1650. Okay, and we want to know how is it going to affect the mean, median, and mode. And then they want you to describe one possible explanation for the outlier. So the first thing we do is we identify the outlier. Then we remove the outlier and recalculate the mean, median, and mode. So you can see that the mean went down by 98%. And that put it right here in the line of the data, much closer to the center of the data now. The median is still close, and the mode is not affected because it's still the most popular. So notice that when you get rid of an outlier, often it makes your data more symmetrical, which means you would now use the mean as your center of measure. So it just depends on how much it changes it, but you want to make sure that if the mean and median are very close, that you use the mean. Okay, why would someone get paid more? So maybe it's someone who is hired to maintain the park's website, so they're going to get paid more because techies get paid more. Or it could be someone who was hired as a manager, even though they're a student. Maybe they had previous experience. So we can think of all different reasons that happens. Okay, we're going to be wrapping up now, but this is a really good example, so hang in there and be glad that I cut this unit in half. So on page 193 of your journal, they have this really good problem, and they want you to complete it without calculations. And I think that's a really good idea because you will see that if you understand exactly what's happening with the mean, median, and mode when there's an outlier. So the first thing they want you to do is look at the masses of 8 gorillas. And you can see all the different weights in kilograms. They want you to identify the outlier. So I'm going to go ahead and put these in order just because that'll help me with the median and the mean and the mode. So I'm going to go 44, 157, 158. So it kind of puts them into my brain as I'm doing them so I can kind of see where I'm going to get an outlier. And I've got them all written down there. The N is 8. There's 8 of them. And I can see that, wow, this 44 is way lower than all the others. And I know if the outlier is low, it's going to pull the mean this way, meaning the mean will be lower. Okay, so you should understand that. The mean is going to be lower than the average or the middle. So if you calculated it, the mean is going to be 145 with the outlier. Okay, and you can see that that makes the mean lower than all the other data. The median of the original is right in between 159 and 160, so it's 159.5. That's our median. And we don't know how much it's affected by the outlier, and our mode is 160. Okay, so now we're going to look at it, and we're going to change. We're going to take out the outlier. So we're going to take out the 44, and we're going to recalculate our mean without the outlier. We expect it to go up, okay, because we've subtracted this one lower number, and sure enough, our new mean is 159.6, which is right here, right where the median is. Our median is going to change because now we only have 7 values, and our median is going to change to 160. So notice that when you're with the median, if there's one outlier, it's going to change by one number. Now, it depends on what the numbers are, how significant that is, but it's usually not very much, whereas the outlier really affects the mean. Okay, and then the mode isn't affected at all. It's still 160. So that's how it affects them. Then they said, describe one possible explanation for the outlier. What could cause one of these gorillas to weigh 44? So think about that, and then maybe it's a baby. So have a good day and good luck with your homework.